The J-15T program represents a systematic and necessary evolution in Chinese naval aviation capabilities, specifically addressing the limitations inherent in the original J-15 design, which was constrained by ski-jump launch operations. The most recent and significant phase of its development has been its successful integration with the new Fujian aircraft carrier, a platform equipped with an electromagnetic aircraft launch system. Confirmed reporting indicates that the J-15T has successfully conducted its initial series of catapult-assisted takeoffs and arrested landings aboard this carrier during its ongoing sea trials. This milestone is not merely a test of the airframe's structural integrity but constitutes a full system validation, a complex process that encompasses the intricate interplay between the carrier's high-power electrical generation and distribution systems, the precise control software of the electromagnetic catapults, the physical interface of the aircraft's launch bar and its massively reinforced landing gear, and the refined pilot procedures required for both launch and recovery cycles. This successful integration marks the definitive transition of the J-15T from a land-based technological demonstrator to an operational naval aircraft now entering the final stages of its qualification for active fleet service. The fundamental capability unlocked by this shift from ski-jump to catapult-assisted launch is the ability for the aircraft to operate at its maximum designed takeoff weight. The previous launch method imposed severe limitations on the mass an aircraft could have at the moment of launch, forcing a critical and tactically debilitating trade-off between internal fuel load and the weight of weapons carried on its hardpoints. An aircraft taking off from a ski jump often had to be lightly loaded, which directly and negatively impacted its combat radius, its time on station, and its overall firepower. The electromagnetic catapult system eliminates this foundational constraint by imparting a precise and massive amount of kinetic energy to the aircraft, accelerating it to flying speed over the short deck length of the carrier, a process independent of the aircraft's weight. This allows the J-15T to be launched in what is termed a full fuel and full ammunition configuration, meaning it can carry a near maximum internal fuel load while simultaneously being loaded with a heavy and diverse payload of advanced munitions. The practical operational impact is a dramatic and quantifiable increase in the aircraft's strike range, its defensive persistence over a fleet, and the sheer volume of firepower it can deliver on a single sortie, thereby fundamentally altering the tactical calculus for a carrier battle group. To withstand the unique and extreme physical forces generated by catapult launches and arrested landings, forces for which the original J-15 airframe was not designed, the J-15T has undergone extensive and observable structural reinforcement. The most visually distinctive modification is the complete redesign of its nose landing gear assembly. This structure is now substantially more robust, featuring a much thicker and stronger shock-absorbing strut engineered to handle the violent forward acceleration and the sudden downward drop upon launch clearance. Integral to this new nose gear is the catapult launch bar, a critical component absent on ski-jump variants. This bar physically engages with the shuttle of the electromagnetic catapult, serving as the direct mechanical interface that transfers the immense force of the launch, often exceeding several Gs, of acceleration, directly into the primary airframe of the aircraft. Similarly, the main landing gear has been significantly strengthened to endure the repeated high sink rate impacts of landing on a moving carrier deck and the instantaneous, jarring deceleration of the arrestor hook engaging a wire, an event that places tremendous stress on the entire rear fuselage structure. These modifications are not optional enhancements. They are absolute requirements for the structural integrity and long-term service life of any aircraft operating in the demanding and unforgiving carrier environment. Beyond these fundamental physical changes, the J-15T incorporates major advancements in its core avionics and sensor systems, which are crucial for modern beyond visual range combat and network-centric warfare. A key observable indicator of this upgrade is the redesigned nose radome. The radome on the J-15T features a different, more streamlined contour and is constructed from a lighter-colored composite material, a change that is consistent with the installation of an active electronically scanned array radar system. An AESA radar represents a generational leap over older mechanically scanned radar systems. Instead of a single, large transmitter that physically rotates to scan, an AESA radar comprises thousands of small, individual transmit-receive modules that can electronically steer multiple, independent and simultaneous radar beams. This advanced architecture confers several decisive tactical advantages. It allows the J-15T to maintain track on a large number of targets while simultaneously scanning a wide volume of airspace, a capability known as interleaving search and track functions. It enables the pilot to engage multiple hostile aircraft with guided missiles at the same time. Furthermore, the AESA radar's agile frequency hopping and highly focused beam characteristics give it a very low probability of interception, making it difficult for enemy warning receivers to detect, and it possesses inherent secondary electronic warfare capabilities, allowing it to function as a jamming platform against hostile radars and communications links. The intended operational role of the J-15T within a future carrier battle group is that of a high-endurance, multi-role air superiority and maritime strike fighter. With the performance limitations of the ski jump removed, the aircraft's large, twin-engine flanker-derived airframe can finally be utilized to its full potential. In the fleet air defense role, the J-15T can conduct long-range combat air patrols at a significant distance from the carrier group, establishing a defensive perimeter with its powerful radar and a full load of long-range air-to-air missiles. For the air superiority mission, its high thrust-to-weight ratio and kinematic performance, now unburdened by fuel and weapon restrictions, make it a formidable platform for contesting controlled airspace. In the maritime strike role, its ability to carry and launch multiple large, long-range anti-ship cruise missiles makes it a primary offensive asset for engaging surface action groups. The increased available takeoff weight also permits the carriage of specialized external pods for electronic attack, reconnaissance, or advanced targeting, thereby expanding the tactical flexibility and self-contained capability of a carrier air wing without relying on external assets. The future deployment and operational readiness of the J-15T are directly tied to the progress of the Fujian aircraft carrier's testing and commissioning schedule. The current phase of testing involves expanding the operational envelope, which includes conducting takeoffs and landings at various weights, testing the integration of the aircraft's avionics and data links with the carrier's combat direction system, and ultimately, conducting live-fire tests of its weapons systems in the maritime environment. This comprehensive process of integration, qualification, and crew training will continue until the entire system, the carrier, its air wing of J-15Ts, and other supporting aircraft, and the supporting vessels of the battle group, is certified for sustained, long-range operational deployments. The successful deployment of the J-15T aboard the Fujian will represent a transformative shift in the capability of Chinese naval aviation, moving it from a regionally focused, defensively oriented force to one possessing a credible, long-range power projection capability centered on a modern, catapult-equipped carrier air wing, with the J-15T serving as its primary heavy strike and air dominance component.